So in this video we are going to understand about the information theory topic, and we will cover the basics, then we will see some example as well. So no problem, everything would be covered from the scratch. So let's start. The first point is the uncertainty. Now what does this mean? Uncertainty. Okay. The first statement, as you can see, India may win the World Cup, and the second statement we have is 1 centimeter is equal to 10 raised to minus 2 meter. Now let me ask you one thing. India may win the World Cup. What do you gain from this? You gain one thing, that India has a chance. If India is not winning, there are some X teams like Pakistan, it can be Australia, it can be England, it can be anything. Correct? If India is not winning, then there are other teams which can win. So as you can see, you are getting more information from this statement, and the probability of India may win is less. There is not a high chance, there is a may. This may word leads to the probability, that there is not a full 100% probability or 99% probability. That's why we have the various chances like the other X teams. Let's talk about the second example. 1 centimeter is equal to 10 raised to minus 2 meter. Now this is a factual statement, correct? Now whenever you see such statement, this means that the probability is almost similar to 100%, or you can say 1. Correct? If the probability is very high, then information is less, because you cannot think further. Wherever there is a chance to think, this means that the information is more. As you can see here, only one statement, so the information is this only. There is no more thinking part involved in this. So from this slide we have understood one thing, that if the probability is less, we are getting more information, like the example 1. And if the probability is more, we are getting the less information, as we saw in the example 2. Now if you have understood this, then you can tell me what is information theory. Now comes the second point. Now you know what is information theory. Information theory is in the formula, that information that is equal to IK is equal to log to the base 2 1 by PK. Now as you saw in the previous example, if your probability is high, information is less, and if information is high, then the probability is less. Okay, that you have understood. We have come with this formula using this concept, that Ik is equal to log to the base 2 1 by Pk. Now comes the unit part. Now because as you can see, this is the part of that unit of the information depends upon the base of the log, because as we saw in this formula, base is 2. This means that the unit is bits, as you can see here. And if the base was E, the unit was nat. If the base was 10, the unit was decet. So this is the next part if we go in the formula terms. So when we talk about formula, what is the information formula? Formula, let us repeat it. Ik is equal to log to the base something 1 by Pk. You tell me the base, I will tell you the unit of information. Clear? So now let us study about the property of information. Now what is that? As we have studied this formula, if we play with this equation, we will get the property of the information. So first thing I have did is, my probability is 1. If I put that in the formula, what will I get? Simple. Let's put that. If I put that, I will get log of 1 by 1, and log of 1 is 0. So my information is 0. This means that I am not getting much more information if my probability is 1. That is the first property. Second property is, if I have many information like I1, I2, I3 and so on, and this information are independent of each other, then I can say that my total information is summation of all of them, provided they should be independent, they should not be dependent on each other. Okay, let's move forward to the third point. Always. Now this is important. Always my information would be greater than equal to 0. Now I have made the smiley sign because my information cannot be negative. My information just cannot be negative. Let's imagine, how can one information be negative? Let's think on that. Like, he's a boy. How does it make a sense that information is negative? So I can see that yes, he is a boy. I will get 0 information. That can be the worst case. So let me take the worst case, that it can be 0. But maximum there can be, like India may win the World Cup, I can get more information from that statement. So always information is greater than equal to 0. It cannot be negative. So let me take the example. This will help you in the academic paper. The example is pretty simple. Message MK is transmitted. So information is transmitted. Okay. Probability of occurrence of this signal is 1 by 4. calculate information conveyed in the terms of bit, nat and decit. Now your information which is conveyed should be in three terms. So your information have the three types: bit, nat and decit. So you have to solve three times. That is the basic idea. Okay, you have to calculate the information and probability is given. So pk is 1 by 4, that is given. First, if you need the information in bit, your base should be 2. The formula remains same. I will write the general formula. Ik is equal to, you have log something into 1 by pk. Okay, and because that something means what, something depends on the unit. They said first in bits, so we take base 2. We took the base 2 and we solved that and we got 2 bits. Second, we need the nat as the unit of the information, so we took the base as e. Similarly, for the third part, we took the base as 10 because our information is in decit. Solve this, you will get the answer. There is a no problem. Just you have to decode that probability is what and what they required. Okay, now this is important. Now this is the variation of the question, and let's see, very important, for the system that transmit m equally likely messages. Now this is important, equally likely messages, and they are giving that this transmitted m messages can be written as 2 raised to n. Then the information in bits is what? So when I talk about the solution, the first point is clear that we need the information. So I will use the information formula, that is Ik is equal to log to the base 2 1 by pk. Now this base 2 is because they need the information in bits. Clear. But the problem here is we don't have the probability. How will I get that? Whenever you don't have the probability, just look at the question once again. For the system that transmit m equally likely messages, whenever you say see this equally likely messages or equiprobable, these are the two terms. This means that the probability is equal for all the messages. That lead me to the first point, that the probability p equal for all the messages, and if you sum up all the probability, highest it can be 1. So p1 plus p2 dot 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 up till m, or you can say n messages, then it would be equal to 1. And because the probability is same and we are transmitting m message, we can say that m into p is equal to 1. Correct? And that's it. If you have this, you can say that my probability is equal to 1 by m, and my m is given as 2 raised to n. Now we are done, because now you know the probability is 1 by 2 raised to n. So log to the base 2 2 raised to n you have to solve, and because you can see this can be took out and n bits is the correct answer, because this calculation would look like n log to the base 2 2, and this value is equal to 1, the log basics, and that's it. You will get the answer as n bits. A pretty simple variation of the question, just you have to think how you can solve. So now we will talk about entropy. The entropy is represented by capital H. The formula is H is equal to, as you can see, summation of I is equal to 1 to m pi log to the base 2 if you are talking about bits, and into 1 by pi. Now this I represents, if you have m messages, then you should take the probability of all of them 1 to m. That's it. And this is how you read the formula and understand that. Okay, and the unit is bits per symbol. Okay, now this means again from the unit you can understand that how many bits are present in one symbol. This means if you are passing one symbol, then how many bits are present in that. Example I can take, if I am writing this 1 in 4-bit format, then it would be 0000. If I am writing 16 in 4-bit format, this would be 1111. So this means that if I am passing this 16 as a symbol, I require 4 bits. So 4 bits for one symbol. This is the unit, and this is how you have to understand. So now let us talk about the property. So property, whenever you study the property, you just have to play with the equation you got. If I put my probability is equal to 1 in this equation, what will I get? This term is now log of 1 by 1, that is equal to 0. So this means that my entropy is 0. Similarly, we have did for the information theory. Like if my probability is very high, my information is very less. Okay, so the first point is clear. Now comes the interesting point, that is the second point. Take a special care, where pk is given as 1 by k. This means that it is equiprobable. If all of the messages have the equal probability of occurrence of transmitting, then what will be the case? My entropy is equal to the maximum value, and the value would be log to the base 2k. Now if you wonder how this value came, Let me take the derivation as well. So the question was, if I have m messages, let's say m1, m2, m3, and let's go on up till m messages with the probability p1, p2, and let's go up till pm. Correct? If messages are equiprobable, that the probability of every message is same, then the entropy is what? Correct. This question is understandable, and we are here to prove that the entropy maximum is equal to log to the base 2 m. So let's start. The first point, the probabilities are same. So if you add all of the probability in the system, then you will get it as 1, because probability range is always between 0 to 1. That is the maths and the probability basics. Okay, so if you have this thing, then you can say that the probability is same, and we have m messages that are transmitted. So m into p is equal to 1. If you rearrange this, p is equal to 1 by m. So once you put the probability in this equation, and if you solve this correctly, you will get the answer. So after expansion of this equation, you will get this term, and as you can see, it is going for the m times. Correct? We are starting with this I is equal to 1, I is equal to 2, and going up till m times. So if you add the same terms over and over for m times, you can say m is my number of times upon the m which came from here. As you can see, in the every equation we have 1 by m. So it came from there, log to the base 2m, and you can solve this. This term has gone, log to the base 2m is remaining, so h max is log to the base 2m. So this was the derivation, this was the reason behind why the entropy maximum is equal to log to the base 2 into m, where m represents the number of messages. Okay, so let's go further. Now this is the variation, and you can see the example. 3 messages are transmitted, m1, m2, and m3, and their probability are 1 by 2, 1 by 4, 1 by 4 respectively. Calculate the entropy. A very simple question, and you can solve this. Pause this video and think. So if you got the solution, it's cool. If you don't, let's follow this step. First point, what is given? The message probabilities are given. So m1 probability is half, m2 probability is 1 by 4, m3 probability is 1 by 4. Okay, now we have to find the entropy. So use the entropy formula. H is equal to, either you can write in two ways, so I will take that down as well. So the standard way we write is I is equal to 1 to, let's say here we can say 1 to 3. 1 2 3, we have 3 messages, so pi log to the base 2 and 1 by pi. We generally consider the base 2 if nothing is mentioned, then we can say the answer would be in bits per symbol. Okay, that's the standard way we go if the base is not given. Okay, so this is the one way to write the formula. The another way is this, using the log property. What was the log property? If you have log of 1 by a, it can be written as minus times of log of a. Correct? This is the log property. So we are using that, and you can solve in this manner also. No worries, because sometimes you get confused why this formula is written in this fashion. Then you should know the logic and the reason behind that. Now you have to just substitute. This is for I is equal to 1, and I have clubbed I is equal to 2 and I is equal to 3 because the values are same, and once you solve that, you will get the answer as 3 by 2. Now this question is homework for you. Let's say my example is I have 4 messages, m1, m2, m3, and m4, and their probabilities are, instead of this I have half, 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 and half respectively. So you can say that what is the entropy, you can calculate. Once you calculate, comment the answer. I will tell whether it is correct or not. And the hint is it is equiprobable. So equiprobable, that example, the derivation we have seen, you have to use the same concept and you will get the answer, no problem. So me too in the comment section for this question. Now let's move forward to the last variation of entropy. Entropy for the extended source. Up till now you know how to find entropy for the x term. Now if you have x raised to n, how will you find? There is a problem, correct? So we have to use this formula. H of x raised to n is equal to n times h of x. So let's take example. If I have my n is equal to 2, h of x is equal to 1.5, then what is my h of x square? Correct, because you know the formula, you can get the answer in seconds. So the answer is h of x square is equal to 2 times of h of x, that is 1.5, and the answer is 3. So 3 bits per symbol. The unit remains same, so unit is same. So I hope you got the entropy concept and the variations and the derivation. So now let us talk about information rate. Now this information rate is represented by capital R, and in this video we are going to cover about the formula, the variations and the gate questions on this topic, information rate. So please watch this video till the end to get the complete knowledge of this topic. Okay, let's start. Information rate is represented by capital R. Okay, I got that, and the formula is capital R is equal to H into R. Now comes the next part. If you don't know how to remember the formula, you can also go by the units. Nobody teach you this method, which is the simpler method. Always go by the units. Whenever I did the speech processing sums or any signaling system sums, I used to go by this method. Physics sums, go by the unit method. So you don't have to worry about this formula. Even if you don't know this, you can solve. And that's my guarantee. Because information rate means per second. So you need information per second. So this means you need bits per second, because information can be represented in bits. Okay, if you need bits per second, then you should have first the bits per symbol, that is entropy. Now if you have the bits per symbol, what you should do to get the bits per second? You should multiply it with symbol per second. Now that is nothing but the small r. Okay, and this is the notation, capital H and small r. That was the formula, and the important point is symbols can be changed with messages in the question or elements or anything. So you don't have to worry about that. You should know the meaning. It can be symbol, it can be message, it can be elements, no problem. Let's move forward to the third point. Sometimes they use sampling frequency as fs to represent the small r. So what is the variation? Variation is in small r. The variation is this small r is not given directly in the question, like symbol per second is this, symbol per second is this much value and you can solve. It is not given like that. What instead what they are giving you the frequency. So you have to go for the sampling frequency, using this frequency using the Nyquist criteria, that is your sampling frequency is twice of fm. And that is what I have written here, that your sampling frequency is twice of your maximum frequency. Actually the Nyquist criteria is fs should be greater than or equal to twice of fm. We generally consider equal to 2 fm for the numerical purpose. So the first point is clear about the formula. Second point is clear because we have studied how to get the answer using the units. Third point, we have cleared about the variation, what would be the variation for the small r. Now let's look at the exact question. We have the first example. Analog signal is band limited to 4 kilohertz. So we have the frequency given in the question. It is sampled at the Nyquist rate and the samples are quantized into 4 levels, Q1, Q2, Q3 and Q4. And if they are independent messages with probabilities P1 is equal to P2 is equal to 1 by 8 and P3 is equal to P4 is equal to 3 by 8, then find the information rate, that is capital R, which is equal to H into small r. And because information rate is in bits per second, you can go by the unit method as well. And let's start. So first point is clear, capital R is equal to H cross R, and entropy you need to get the entropy. Let me take this also. To get the entropy you should need the probability, and the probabilities are given in the question here, so no problem. So what you have to do, use the entropy formula. Now the base is 2 because we are considering this as the bit. Okay, not decit and nat, we are considering it as bit. Okay, so log to the base 2, that part is clear, and we have to use the formula. So because we have the 4 level, it would go from I is equal to 1 to 4, correct? And as you can see, first term, second term, third and fourth term are added, so you can see this 2 is multiplied, correct? And that's it. If you solve this, you will get 1.8 bits per message. Let's move forward. Now you have the H, now you need R. So R is not given directly, instead frequency is given. So small r is equal to your sampling frequency, that is equal to twice of the maximum frequency, that is 4 kilohertz. So twice of 4 kilohertz is 8000 messages per second, that is your unit for small r. Now you have to multiply these two terms, H and R, and you will get the answer, and the answer is 14400 bits per second. Now this question is homework for you. As you can see, P1, P2, P3, P4 is given as 0.1 and the rest probabilities are this. So you have total 16 levels, so 16 probabilities. If FM is given as 3 kilohertz, then find the information rate, that is capital R. So the steps are given. First you have to find H, then you have to find R, then you can get the answer. And what is the formula of information rate, you should know. And that's it. If you need the verification part, then the h value is here. Small r you can get directly by looking at the question. And please answer the comment so that I can tell you whether your answer is correct or not. So this was homework for you, and let me cover you the last variation of this topic, information rate. So let's see. A source generate 1 by 4 message randomly every microsecond. Suppose 4 messages are generated with the probabilities as this, and they are independent messages. Find the R, that is information rate. Okay, information rate is H cross R, and entropy you can find because probabilities are given. So again we have 4 messages, so I is equal to 1 to 4. You have to use this formula, put in the values, get the answer would be 1.84 bits per message. Correct. Now you need the third point, that is small r. Small r, no f is, so this is the second variation. F is not given. If f is not given, we cannot find fs, correct, and we cannot get r. But instead use this first line and use your knowledge. Your knowledge is, your unit of small r is message per second. Again you have to understand this unit, message per second. So if you see the first point, a source generate 1 by 4 message randomly every microsecond. So it is generating one message, as you can see here, one message every microsecond, that is 10 raised to minus 6. So small r is equal to 1 by 10 raised to minus 6 message per second. And once you get r, then the answer is simple. Capital R is h into r, and the answer is 1.846 mega, you can say, bits per second. So this capital M means mega, that is 10 raised to 6. That's it. So this was all about the information rate, and gate questions will be covered in the future videos, so do not worry about that. The basic idea remains same. In the gate question you are applying the same knowledge. So up till now we have covered a good basics, so let me take some gate questions so you will get some confidence. Okay, let's start. Gate 1989 2-mark question. A source produce 4 symbols with the probability 1 by 4, 1 by 2, 1 by 4, 1 by 8, 1 by 8. For this source, practical coding scheme has an average code word length of 2 bits per symbol. Okay, then the efficiency of the code is what? Now efficiency means capital H by L. Capital H is entropy, L is the average code word length, and it is given as 2 bits. So no problem, we have this, and we need H. To get H you should have the probability, which is given P1, P2, P3, P4, everything is given here. Okay, if everything is given, then just put in the formula. H is equal to minus summation of I is equal to 1 to 4, because we have 4 messages or 4 symbols, as you can see. So put that value, solve this, and this part is clubbed. I3, I4 are clubbed and written down here in one term, and that's it. Once you solve this, you will get the answer as 7 by 4 bits per symbol. That's it, that was the unit, and that's it. Once you get this 7 by 4, so plug in that value here, 7 by 4, and the L was 2, so the answer is 7 by 8. A straight question, no manipulation, just you should know that efficiency is H by L, and it can be written as L minimum by L, so no problem. So L minimum and H are same, you should know that. And that's it. L is always given in the question for gate purpose, and H is the entropy. You know the formula, no doubt in that. Okay, let's move forward. Now this is the similar question gate 2016. As you can see, when we proceed in the future, the past question was a 1989. Now it's the present 2016, so it's not the present but close to the present, you can say. Gate 2016 1-mark question. Source with the symbol A1, A2, A3, A4 with the probability 1 by 2, 1 by 4, 1 by 8, 1 by 8. The same question, same. Minimum required average code word length in bits to represent this source for error-free reconstruction is what? Minimum. As you saw the word minimum, you should know that they are talking about the average code word length minimum. So L minimum is what? L minimum is H, as we saw in the previous slide. So if L minimum is H, then you have to use the entropy formula, and because we have the 4 symbol, I is equal to 1 to 4, and base is 2. Important point, base is 2, because we are talking about bits, and that's it. Once you solve this, you will get the answer as 1.75 bits per symbol. Pretty straight question, but you should know your concepts right. So now let's move forward to the next question, gate 1992 mark question. An image uses 512 into 512 picture elements. Each of the picture elements can take any of the 8 distinguishable intensity level. Maximum entropy in the above image will be, so you have the options. Okay, so let me take some different color and it would be better. Let's say yellow. Okay, so now this is clear that we have the image that is 512 into 512, and we need what? We need maximum entropy. And because they are talking about bits, we have to understand one thing: they need maximum bits. If they need maximum bits, we should understand what maximum pixels we have. We have 512 rows, 512 columns. So 512 into 512 into some bits, because every pixel can be represented in some bits, but we don't know how many bits are there. We have to understand the question to get this answer. So if this pixel is represented in 2 bits, you can multiply 2 here. If it is represented in 3 bits, you can multiply 3 here and get the answer. So how we will understand whether it is 2, 3, 4 or something? Now comes the next part. Now each of the picture element, each pixel is distinguishable in 8 intensity level. Now this is interesting. Whenever, so this is the answer for that thing. Whenever you have 8 levels, this means you are going from 0 to 7, correct? And for this you can say that I can represent this in bit format, 2 raised to 3 bits. This means that now this is not the bit format, we are getting the bit format like 3 bits. So you can represent 8 levels in 3 bits. If I had let's say 16 levels, then it would be 2 raised to 4. This means 4 bits. Let's say I have what I can say, I can have 4 level, then it is 2 raised to 2. This means 2 bits. So I hope you are getting the point. If it is 8, then 2 raised to 3, this means 3 bits. If I have 16, this means 2 raised to 4, means 4 bits. If I have 4 levels, this means 2 raised to 2, that is 2 bits. So if you got this, you can say that this 0 can be represented as 000 in 3 bits. This 7 can be represented as 111 in 3 bits. So one element can be represented as 3 bits if you are distinguishing this pixel in 8 levels. And then you should tell that you have to multiply this with 3 and the answer would be this. So pretty simple question, but again you should know your basics right. So now let's solve GATE 2006 2-mark question. A source generates 3 symbols with the probabilities as this, okay, at the rate of 3000 symbols per second. Assuming independent generation of the symbol, most efficient source encoder would have the average bit rate. So we need the bit rate, and A, B, C, D are the options for you. Bit rate means bits per second I have to find. I got this. For just by looking at the question, I got what I need, bits per second, but how I can get, that is the next question. So I have to remember the information rate video. Once I get that, then I can say capital R is R into H, and that is the case. Capital R is R into H. R means we should have some symbol per second, and H means we should have some bits per second, sorry, bits per symbol. So as you can see, H you can find, so this is the formula, summation. Because we have 3 symbol, I is equal to 1 to 3, solve that, you will get 1.5 bits per symbol. So the unit is what, as you can see here, so entropy, bits per symbol. Moving forward, you should need you should have small r is given 3000, so multiply that with entropy. Final answer 1.5 into 3000, answer is 4500 bits per second. So answer is what? Answer is B. So B is the correct option. A is wrong, C is wrong, D is wrong. So in this way you can solve the sum if you know the information rate video correctly, and that's why I said always please watch my basics video. Once you know that, surely any question you can solve, that's my guarantee. As you can see, this next question, GATE 2016 1-mark question, because you know my basics video, this is a cakewalk for you. As you can see, an analog base signal band limited to 100 Hertz, so F is given as 100, is sampled at Nyquist rate. The samples are quantized in 4 messages, symbols with the probability as this. Okay, I got it. Information rate, bits per second of the message, source is what. So first, information rate is capital H into small r, and capital H can be found using the entropy formula. And the probabilities we don't have exactly, there is one more step here. As you can see, one more step, because P2 is equal to P3, that is given in the question, but not the values of them, P2 and P3. So we have to find. If we sum up all the probability, we get that is equal to 1, because P2 is P3. Now my unknown is only, so these two are equal, P2 and P3. So my unknown is only 1, because I can write P2 plus P3 as 2 times P2, and I can solve because P1 and P4 are given as 0.125. so after solving that, I will get 3 by 8. So P2 is 3 by 8, and I can say that P2 and P3 are same, so P3 is also equal to 3 by 8. So now I can get the entropy. Okay, I got the entropy as 1.811 bits per symbol. So when I talk about this small r, what can I say? My small r, because this f is given in the question, 100 hertz. So fs, small r is fs, that is equal to twice of the maximum frequency, and the frequency here is 100. So 2 into 100, that is equal to 200 samples per second. This concept you know because you have seen my video where I have covered every variation on information rate topic. And that's it. Once you get this, then you can say the capital R is equal to H into small r, which is 200 into 1.811, and the answer is 362.2 bits per second. So let's move forward, and this is the GATE 2014 2-mark question. As you can see, a fair coin is tossed repeatedly until a head appears for the first time. Let L be the number of tosses to get his first head. Entropy H of L is what? A very interesting question, because no probability is given. Instead, they are telling that a fair coin is tossed repeatedly, so infinite times, repeatedly, until head appears. Okay, for the first time, that is also important. So probability of head appearing in a coin is half. So first point is number of tosses, 1, 2, 3 up till infinity. Second point, probability is half when we talk about the first toss. But when we do the second toss, this means we have lost in the first toss, and when we did the first toss, we didn't get the head, and that's why P2 is equal to the first time, that is half, and then you are trying for the second time, that is half. So half into half. P3 means first time you tried, second time you tried, and third time you are trying. Still you are then you are saying that I am getting the first head. That is your assumption, and you are going up till infinity. So that is clear. Okay, then you should know that the entropy formula is this: summation of I is equal to 1 to infinity. Now we are going pi log to the base 2. Okay, because we have only two possibilities, heads or tails, so the base is 2, and 1 by pi. So this is a very interesting question, and as you can see, once you have this equation, you can write it down in this format also, because log to the base 2, 2 goes with 1, and this can be written as 2 square. 2 can be taken as outside the log, and again this is 1. So do this repeatedly, you will get this term. Now comes the interesting part. If you don't know the series expansion, then also you can solve this question. How? Let me take that. So because you have this equation, you can say that my half value is equal to 0.5, my 2 by 4 value is again 0.5, so now I am getting 1. 0.5 plus 0.5, I am getting 1. But my 3 by 8 value is 0.3, and 4 by 16 value is 0.25, 5 by 32 value is 0.1, and it is decreasing drastically. Now it would be 0.0 something, then 0.00 something, 0.0000 something, and so on. Correct? But from here I can getting the idea that from here I will get 1, then I will get 1 plus 0.3, that is 1.3. Correct? Then I'm adding plus 0.25 plus 0.25, so I'm getting 1.55, and again I'm adding 0.1, so 1.65. But now it will go from 0.001, 0001, so hardly I will get my answer similar to 2. Okay, if you go up till infinity, I will get my answer similar to 2, not more than that, and that's why the answer for this question is 2. So this is how you can go if you don't know the series expansion. The same question has asked, as you can see, it was in 2014 this question was asked. Now in 2016 they are asking the same question. So the question is, consider discrete memoryless source with alphabet as given S0, S1, S2, S3, infinity, and respective probability are this. Okay, 1 by 2, 1 by 4, 1 by 8, and this is making the calculation even simpler. Entropy of the source is what? In bits. Okay, so H is equal to summation pi log to the base 2, 1 by pi, and I goes from 1 to infinity. You don't know the final value. Okay, so once you do that, you will get the answer, because now you know the expansion, the logic behind the answer too. So this was the simple question, but you should know your basics, right? So now we will talk about channel capacity theorem. Now the formula is simple. C, that is the channel capacity, as you can see, So I will take this color, it would be better. Channel capacity C is equal to bandwidth into log to the base 2 1 plus P by N. Now B means what? B means bandwidth, and P by N means what? P by N means power to the noise ratio, or it can be signal to the noise ratio. Anything is valid. So once you know the formula, you can solve this sum. That is my guarantee. So let's look at the GATE 2009 sum. So let's read the question. A communication channel with AWGN, this is additive white Gaussian noise, operating at SNR ratio greater than 1. Okay, so this is the first condition, and bandwidth is B only, no problem, and we have the respective capacity as C1. If the SNR is doubled, so this is the second condition, if SNR is doubled, keeping the bandwidth constant, resulting capacity C2 is what? So A, C2 is similar to 2 times C1, B, as you can see, C and D, these are the options. But which is the correct and how we have to proceed? First, you should know that this is the channel capacity theorem based question, and once you know that, you can say that my channel is capacity is equal to bandwidth log to the base 2 1 plus P by N. Now comes the next part, because the first condition, first point is SNR ratio is greater than 1. So if this is very greater than 1, then as you can see, if I add 1 in million, then it would be similar to million, there would be no change. So if my P by N ratio is very high than 1, then P by N plus 1 is similar to Pn. Pn can be written as S by N, because SNR is the given ratio, so I have changed this term in S by N, and the rest remains same. C is changed with C1 because that was for the condition 1. Now the condition is changed, that is the second point. SNR is twice of SNR and bandwidth is equal to bandwidth, no problem. So if I do that, I will get the channel capacity C2 is equal to bandwidth log to the base 2 twice of S by N, because they are doubling the ratio. So if I do that, I can split this, because I can use the log concept. Log of AB is equal to log of A plus log of B. I'm using that concept. So this is my first term, this is my second term, and splitting that. So if I split, I will get this, correct? And now you can tell the answer. Log this term is 1, log 2 to the base 2, answer is 1, and B is remaining, so C1 plus B is the correct answer, so answer is B. A pretty simple question, correct? But now what if I do some variation? My formula was this: capacity is equal to bandwidth log to the base 2 P by N. Now what if I say my bandwidth tends to infinity? What if I say this, my bandwidth tends to infinity? Then I can change this noise to N naught B. If my bandwidth is going very high, then P by N naught B will decrease surely. And if it happens, I can say that my channel capacity for infinite bandwidth is equal to 1.44 P by N naught. And its derivation is available, derivation. If you need the derivation, tell me in the comment section. I will prove that as well, that C infinity for the infinite bandwidth is equal to 1.44 P by N naught. Now the second case is, what if I say my channel has no noise, noiseless channel? Then my N is 0. If my N is 0, then P by 0, this means infinity. If my capacity is infinity, I am happy that my capacity is infinity. I can send many information as I want. There is no noise in my channel. So when noise is 0, capacity is infinity. That was the next variation. So I hope you got the variation. Then only you can solve this GATE 2014 1 mark question, as the capacity of the bandwidth AGWN channel is given by this. Okay, bits per second, no problem. W is the bandwidth of the channel, notation has changed, and sigma square is one-sided power spectral density, that is nothing but noise. P is equal to average power received for fixed P by sigma square, that is equal to 1000. Channel capacity with infinite bandwidth, very important line, channel capacity with infinite bandwidth is approximately equal to what? Channel capacity with infinite bandwidth, channel capacity with infinite bandwidth is 1.44 P by N. Yes, I got the answer. Answer is 1.44. 10-second question is solved. But if you don't know, you have to do the derivation. You have to get the answer. It's a very time taking if you don't know the concept, if you don't know the variation. And that's it. Once you know the variation, it is simple. One-liner answer. C of infinity is equal to 1.44 P by N naught, where N naught here is sigma square. No big deal, but the answer remains same, 1.44.
तो फ्रेंड्स, अगर आपको मेरी वीडियो पसंद आ रही हो then do like this video, share with your friends and subscribe to my YouTube channel. तो मिलते हैं अगली वीडियो में. Till then, take care. This is 𝐀𝐍𝐃𝐑𝐦, peace out.